Welcome back, everyone. Now, I know in the last few lessons, we wrote a lot of new Saga code, and we had to refactor our code quite significantly. And we were introduced to all these new Saga concepts, such as take every, take latest, put, call, writing the sagas themselves, yield statements, try catch blocks. There's just so much code that we wrote that amongst the process of coding all of that out, I am worried that we might have gotten a little lost in what it is that we were trying to accomplish. So what I want to do in this lesson is just take some time and not look at any code at all and just understand conceptually what it is that we just wrote. Let's begin with our new fetch collection sagas. Well, looking back at that Redux saga diagram that we had before, I've slightly modified it a little more now so that it matches what we just wrote regarding our fetch collection saga. So what we did was that we still had our components that dispatch the action of fetching our collections, except now we're fetching a new fetch collections start action. So we broke out all of our asynchronous related fetching actions into start, success, and failure actions. And our component is the one that ends up firing the first action to start fetching those collections. This action makes it to the middleware, right? Our saga middleware, which then dispatches it into all the sagas. And we happen to have a saga that's listening for that fetch collection start, which is our fetch collections start saga. This saga listens for that action that we just dispatched from our component, and then it fires off its own function call, yielding to another saga, which was our fetch collections async saga. So the moment this saga heard this fetch collection start, it then took that action and passed that action into whatever other saga we wanted to fire based on that action. Now, how we caught and passed that action into the next saga was using any of those take methods. So when we used that take latest or take every method, we were essentially doing just that. This saga was saying, I'm going to take every single fetch collection start action, and then I'm going to do something with it. Whatever that something was is that next saga that we passed into that take latest or take every function call. The moment that fetch collection async generator function got called, this ended up doing the actual stuff that fetched our collections from our Firestore. From this saga then, depending on whether or not we were successful in getting that collection or not successful, we would end up dispatching a new fetch collections success or fetch collections failure action. And then that action goes back into the saga middleware. The saga middleware passes them to all of our sagas, but because we have no sagas that are listening for these actions, it just passes those actions to the reducers, and our flow goes back to normal. So this saga middleware literally is like a step in between all the actions being dispatched before they make it to the reducers, and then it performs some actions that are asynchronous in nature, such as fetching collections from the Firestore library that we have. And then it will dispatch new actions of success or failure, which finally make it to our reducers that then update their reducer states with the values that we got back from our Firestore. So if you think about it like that, from an image standpoint, it's actually much more simple. The code we wrote was much more extensive because we had to deal with that take latest and that take every, as well as that put. But those are really just the means in which we were able to move on to the next step inside of this diagram. Take latest and take every being what allows this saga to actually catch this fetch collection start action that the saga passes to all of our sagas. And then, depending on what the success or failure of the actual fetch call from the Firestore was, we put out new fetch collection success or fetch collection failure actions. So put is essentially the saga way of dispatching new actions. So this was what we were doing with our Fetch Collections saga. Now, with our sign-in sagas, if we look at this other diagram, we'll see that it's very similar. The only difference now is that we have two different stream paths for what sagas could have done. We still had a component that would dispatch new sign-in actions, either email sign-in start or Google sign-in start. So those actions go into our Saga middleware, and our Saga middleware will pass all of those actions to all the sagas. Now, we happen to have a on Google sign-in start saga that is using take latest on Google sign-in start. So the moment it hears that Google sign-in start action, it's like, oh, okay, I'm going to take this, and then I'm going to call my sign-in with Google saga, right? That new generator function that we had. This sign in with Google generator function has all the code to sign in with Google. And then what it will do, depending on the success or failure, is dispatch new sign in success or sign in failure actions, which go back into the Saga middleware. Saga middleware determines that none of the sagas need or are able to consume those actions, and then it passes those actions to the reducer. If we had instead email sign and start, our email sign and start method hits our Saga middleware. That goes into email sign and start. Email sign and start is also using take latest to listen for the email sign and start action, and then it will take that action and pass it into our sign in with email and password generator function. This function then has the code to sign in with email and password, just like our sign in with Google, except with sign in email and password instead. And then depending on the success or failure of that, it will dispatch the exact same actions that sign in with Google did, because our sign in success and sign in failure actions are generic enough that our reducers are simply able to update the exact same way based on what the sign in was successful or sign in was a failure. The only difference was the requirements inside of these two generator functions. One needed to sign in with our Google, and one needed to sign in with email and password. As far as the actual actions were concerned, they were exactly the same, because what we got back from both these sign-ins was going to be the exact same user object. The data for our current user was the exact same. So our reducer only cares that the method sign-in success gets fired, I get that object, I store it inside of my reducer state. Now, we're able to do this because our sign-in with Google method on our auth library and our sign-in with email and password method on our auth library both return us the same thing when it comes to the errors if it fails, but also the objects if it succeeds. If the sign-in is successful, we get the same snapshot object of the user. So with that object, we're able to simply dispatch the exact same sign-in success method. We don't need to duplicate and make two different actions that end up doing the exact same thing in our reducer, which is simply updating our current user value to that new value. So with that in mind, hopefully this makes sense. The only thing we're missing now from the old code we had before the refactor was session persistence. Because before, what we did is we had our app component that when it mounted, it would fire off and instantiate that auth.onAuthState changed method, which would immediately let us know whether or not the user is still signed into a session. We don't have that code anymore because we've moved everything into sagas. And the only time we ever dispatch these sign and start actions is based on whether or not a user has clicked either of the buttons that trigger these actions inside of the sign-in component. On mount now for our application, we have nothing checking against the auth library to see whether or not the user is still valid in the session. What we're going to do then in the next lesson is we are going to write new actions that will check against that auth library to see whether or not the user session is valid or not. That code we're also going to put into an app mount so that the moment our application boots up for the first time, we're going to check against the auth library to see if our user is still persisted. That is how we're going to pretty much break out all of the code into sagas from a conceptual level. So hopefully now equipped with the mental model in what it is that's happening when we write our sagas, it'll make more sense with the new saga we're going to write in the next lesson.